Hi everyone, I am Tejashwini and we have been discussing about the best practices of software engineering part 1 and part 2, and now I am going to discuss about the best practices of software engineering part 3, which is the programming and coding. And before going to that, I'll give you a short review of part 1 and part 2, and this is the part 1, which is introduction and overview of 50 best software practices. And we all know that in 21st century there is a recession happened in September 15, 2008. At that time there is a lot of minimizing harm from layoffs and downsizing, and we also know that there is only 70% of projects completed and 50% ran over twice, and $81 billion spent in the cancelled projects. So these are the different 5 problems occurred with cancelled or disastrous projects, which is estimates prior to starting the project were inaccurate and there's no quality and change control, and these are the different problems that are faced in the previous 90s. And software engineering development problems, because this is an inaccurate understanding of end users needs, inability to deal with changing requirements, modules that don't fit together, and these are the different problems that are faced. And firstly, we need to know why we need practice, because we need a practice that will serve as a framework for large-scale and small-scale projects and adapt to, embrace changes, opportunity for improvement, not identification of failure, and it is iterative, risk-driven, and architecture-centric. So identify the best ways of doing things, a better process acknowledged by the world leaders. And this is the common iterative process of a project, that is, we are having a requirements, design, code, integration, and test. And these are the drawbacks like risk inadequately addressed, process not receptive to change, problems not really seen. All these are different problems for iterative progress. And so the best practices of software engineering, these are the different main concepts, which is develop iteratively, manage requirements, use component architecture, model visually, verify quality, and change control. These are the main components of best practices of software engineering. So the best practices are a set of empirical proven approaches to software development. When used in combination, they strike at the root causes of software development problems. So they are called best practices not because we can precisely quantify their value, but rather they are observed to be commonly used in industry by successful organizations. And we'll discuss what are these components. First one is the develop iteratively. In the develop iteratively, we are going to develop our project in the different iterations like iteration 1, 2, 3. And this develop iteratively is a critical risk are resolved before making large investment. Initial iterations enable large early user feedback, and testing and integration are continuous. Objective milestones are provided for short-term focus. And so the develop iterative is very important for any project. And management requirements. We need to manage our requirements initially because requirements are dynamic, expect them to change during the software development. So users' own understanding of the requirements evolves over the time, and we need to change our requirements continuously for a better feedback and better quality output. So maintain forward and backward traceability of the requirements are very much important. The third one is use component-based architecture, and using the component permits the reuse of the available materials and choice of thousands of commercially available components. And this is a particular component-based architecture having a different layers with the application-specific, business-specific, middleware, and system software. And so the using of the component-based architecture means provides a clean division of work among the teams of developers. And the other one is visually model software. The visually modeling improves our ability to manage software complexity, and we have different models for we can draw the diagrams. So they capture the structure and behavior of the components. And here we have many models, that is use case diagrams, class diagrams, objective diagrams, and component diagram, deployment diagrams, activity diagrams, state diagrams, and collaboration sequence diagrams. And these are very much useful for the design purpose. So they capture the structure and behavior of the components and promote unambiguous communication. This is a simple example by the IBM visual model software structure. And the fifth one is the verify software quality. The quality is very much important in every project. So we need to know what is the quality, the characteristic of producing a product which meets or exceeds agreed upon requirements by some agreed upon objective measures. So there are different testings are available. So we need to test every single module by either by unit testing or different type of testing. And software problems are 100 to 10,000 times more costly to find and repair after deployment. So develop test suites for each iteration, functionality, reliability, and performance. So software quality is very much important for any product that should be reached to the customer or the client. The sixth one is change controls to software. Without explicit control, the parallel development degrades to chaos. Decompose the architecture into subsystems. So initially we need to develop our system. So we need to decompose our system into subsystems and assign the responsibility of each subsystem to a team. Then establish an enforceable change control to mechanism where change requests are prioritized, impact of the change request is assessed, and plan put into the place to introduce change in a particular iteration. And this is a simple diagram of generic change control process. Initially we have the software change and problems, then analyze the simple assessor of impact and prepare change purposes and evaluate them and give it and incorporate into the change, and then we need to verify, then we'll give to the supplied feedback, and if the process is not end, we'll have a continuous feedback chain. So change control is also very important and it is also one of the best practice. So the best practices are commonly develop iteratively, manage requirements, use component architectures, model visually, continuously verify quality, and manage change. These are the main components of the best practices and their corresponding activities and functions. Let's see what's the 50 best practices, and these all best practices projects are focused on 10,000 function point range, and the set of best practices discussed here spans the entire life cycle from the day a project starts until the day that application is withdrawn from the service. And these are the 50 best practices, which is minimizing harm from layoffs and downsizing. We'll discuss all this together and we'll have a short review on this. The first one is best practices for minimizing harm from layoffs and downsizing. So we need to minimize those harms from layoffs and downsizing by analyzing and prioritizing the applications that are under development and analyze maintenance of existing legacy applications. And there is no perfect solution for downsizing and the layoff personnel, but cutting the specialist and administrative personnel in large numbers may cause unexpected problems. So all these we need to check together. And in 2008, the IBM spent $700 millions in employee restructuring actions. So the CEO took a 20% cut while the other employees forfeited between 2.5 and 15% of their pay. So the we need to control like minimizing harm from layoffs, and this is the basic examples. We also seen that there are many layoffs happen in many companies like Zomato, Uber, etc. And the other one is the best practice for motivation and morale. This is always discussed. It's very important. And the other is best practice for selection and hiring the software personnel, and best practice for appraisals and career planning for software personnel. And this is a basic example. Then best practice for early sizing and scope control of software applications. And this is the best practice for outsourcing software applications. Outsourcing is very important because by having an outsourcing, we are taking the other person from the company to as a contractor. So outsourcing helps us to save money and the time. So outsourcing is a best practice nowadays. So we all should employ to learn that one. This is a basic example for the outsourcing, and the advantages of outsourcing is it can save cost, can promote efficiency, you can keep operational control, offers staffing flexibility, and provides continuity and risk management, and you can develop internal staff. These are like using contracts and management consultants, and selecting software methods, tools, and practices also very important. These are the different development methods and partial development methods. Certifying methods, tools, and practices. Certification is very important for every software personnel in order to identify what the stage he is up to, and certifications gives a better opportunities in our life. So there is a 4-layer taxonomy: nature, scope, and class type. And the other one is a best practice for requirements of software applications, and we need to gather and analyze the requirements based on our requirement, and we have a requirement engineering, modeling, integration, static and dynamic analysis, test verification, automated testing, target IDE, enterprise, etc. And this is the other practice: user involvement in software projects. So, and the other one is software architecture and design is very important in order to avoid the errors initially, and software project planning also important. The other one is software project risk analysis. Risk analysis is very much important in between the design and the deployment phase, so we should have a risk analysis properly. And software project value analysis, and practices for cancelling or turnaround trouble projects. And these are all the 50 best practices we have all been discussed previous video. And this is a best practice for programming or coding. We'll see in the part 3. And best practices for software quality assurance. Here I have discussed like CMMI and Six Sigma or the best software quality product softwares, and testing and test control library, and software security analysis also very important in order to save our data, and international software standards we need to maintain, and best practice for protecting intellectual property in software, and we need to protect against virus, spyware, and hacking, and the best practice for software change management after release. And this is somewhat little disadvantage because we need to manage our changes before the release, and best practice for updates and release of software applications. And the least one is best practice for terminating or withdrawing legacy applications. So we have a different categories of solutions for legacy information, and which are freeze, outsource, carry on maintenance, discard, wrap, and migrate. And the best practice for retiring aging systems or mine the application to extract business rules, survey all users to determine. This all been discussed in my previous video. So there are 100 ways to make a large software system fail. There's only a few ways to make them successful. Among the most important software development practices are those dealing with planning and estimating before the project starts, with observing change requirements. So software engineering would benefit the global economy and our professional status to move software engineering into the ranks of true engineering fields. A combination of defect prevention method, inspection, static analysis, testing, and quality assurance are needed. As security threats against the software increase in numbers and severity, fundamental changes are needed in software architecture, design, coding practices, and defensive methods. So large software applications last for 25 years or more. Methods and practices must support not only the development but also deployment and many years of maintenance and enhancement. Thank you.